Okay, this is 2020 AP review question number 5. Okay, so it says draw a Lewis structure for Cl03 -1 in a box below that obeys the octet rule. So the first thing that I would do is take this Cl03 and I'm going to add up how many valence electrons it should have. Well, chlorine has 7 valence electrons, so there's 7. Okay, oxygen has 6, so 6 times 3 is 18. So 17 plus 18 equals 25. But if you notice, this thing's -1, so that means you got to add one more. So that's 26 electrons. So I'm going to put chlorine in the middle, and I'm going to connect it to 3 oxygens. And then what I'm going to do after I do that is this one, it wants it to obey the octet rule. So I'm going to go ahead and put 8 electrons around everything. So 2, 4, 6, the bond count is 2, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. Okay, now everything has 8 around it, so then I'm going to count 6, 12, 18, 20, 22, 24, 26. Hey, that matches my number, so that's the right thing. And then I'm gonna the right way to do it anyway. And then I'm going to put brackets because it's an ion and put the charge of the ion, which is 1 minus, on the outside of the brackets. Okay. Now, what is the formal charge? Okay, so the way that I do it is I just think of it this way. Expected electrons, like how many electrons does something have? And that's basically the valence electrons. Okay, minus the electrons shown. All right, so let me show you how I would do this here. Okay, oxygen, okay, has 6 valence electrons. Now I'm going to count how many is shown around it. So 2, 4, 6, and then the bond I only count as half because one part of the bond is oxygens, one part's chlorine. You can think of it like that. So 6 minus 7 equals -1. So this formula charge, or formal charge on this oxygen is -1. You can see all the oxygens are exactly the same, so they're all going to be -1. Okay, then chlorine. Okay, chlorine has 7 valence electrons, minus, so that's expected, minus. Let's see how many are shown. So there's 2, 3, 4, 5. So 7 minus 5 equals +2. So the formal charge on the chlorine is +2. Now, one rule about formal charges and Lewis structures and all that is the sum of the formal charges must equal the charge on the ion. So 3 -1s and 1 +2 gives you a net of 1 minus. So we probably did the formal charge right. Okay, what is the hybridization of the chlorine? Okay, well the chlorine, I'm not going to draw everything here, but chlorine has 3 oxygens, chlorine, not carbon, and a lone pair. So you count the domains. So we got S, P, P, P. So it ends up being sp3. All right. Okay, now after doing some research, the student finds the following accepted Lewis structure. And you can see that this one violates the octet rule, and it has like things got more than 8 around. The chlorine has more than 8 around it. And if you Google this, this is what you might find, okay? And I don't think AP would ever have you draw something like that, but they might have you try to justify why this structure might be better than the structure that you drew, okay? And so one way to do that is to assign formal charges. Okay, so let's start with this oxygen right here. Okay, now oxygen has 6 valence and it's showing 2, 4, 6, 7. So 6 minus 7 equals -1. So that oxygen's -1. Okay, let's do this oxygen over here. So oxygen has 6 valence electrons, 1, 2, 3, 4, 5, 6. So 6 minus 6 is 0. So this one has a formal charge of 0. If it's 0, normally people don't write it. and this one is the same as this one, so this one's also 0. Okay? Chlorine, it has 7, and it's showing 1, 2, 3, 4, 5, 6, 7. So 7 minus 7 equals 0. And so that chlorine is 0. Okay, so anyway, now the sum of our formal charges equals the charge on the ion. Okay, so why is this structure more plausible? Like, that means it's more likely than the one that we drew on the other one. Okay, well, basically, a structure with fewer formal charges is more plausible than one with more formal charges, okay? So the fewer formal charges is more plausible. Okay, now there's also this thing about bond energy. Okay, now you would think that if you looked up at this structure right here, you would think that hey, the bond energy is going to be different for a double versus a single, but in reality, you could draw resonance structures of this, which means that the true structure of this, the bond between the chlorine and the oxygens, is somewhere in between a single and a double bond. Now, if you go back and look at the other Lewis structure that you drew, these are all single bonds. Okay, so these would have single bond energy, which would be this 198 kilojoules. Okay, but a double bond is 379 kilojoules, but the research the student does finds it to be 322 kilojoules, which is somewhere in between a double bond and a single bond. So that's one reason why this structure is also more plausible, is because the bond energy is between a double and single bond energy, which would be more like this structure than the structure on the other page. Okay, next we have a kinetics problem. So we got to determine the rate law from this experimental data. So how I would do it is just say, okay, find KMNO4, find where it's changing and the other ones are not. So trial 2 and 1 would be great. So I always take the big number divided by the small number to some power, let's just call it m, is going to equal the rate 8.56 e to the minus 8 over the rate when it's 0.1 molar, 3.42 e to the minus 8. So you can see, hey, changing the molarity did make the rate change, so we know it's not 0 order. Okay, and so if you do the math for this, you end up getting 2.5 to the exponent m equals 2.5. So 2.5 to what power? So m equals 1. Okay, so that's for the KMNO4. Now let's do the NaClO3. So we got to find where it's changing, but the other ones are not. So I'm going to do this trial right here, 3 and 1, because notice on 3 and 1, this is the same and this is the same. So we take 0.300 over 0.100. Okay, and we take it to some power. We'll just do n for this one, is going to equal, I take the big number, 1.03 e to the minus 7. Well, not necessarily the big number, but the one that matches the 3 there. So the 3, I got to use its rate. And the 0.1 is 3.42 e to the minus 8. And if you do that for this one, you get 3 to the n power equals 3. So n equals 1. So I guess I should write, this is the first order, this one's first order. Okay, now let's do the HCl. So we got to find where the HCl is changing, but the other two are not. So I'm probably going to do trial 4 and trial 1, because if you notice on trial 4 and 1, these two are staying constant. Okay, so I got 0.200 over 0.100, and we could say, let's just call it x. I'm running out of good variables. And so this is going to be equal to 3.42 e to the minus 8 over 3.42 e to the minus 8. So I get 2 to the x equals 1. And remember, anything to the 0 power equals 1, so x is equal to 0. Okay, so the rate for this is 0. Okay, so then the rate law, I'm just going to write it up here. The rate law, rate will equal k, and then it's going to be k mno4. That's to the first power. The NaClO3, that's also to the first. Now I'm just going to leave out the HCl because it's to the 0 order. Anything to the 0 order isn't going to affect the rate. It doesn't affect the rate, so it doesn't. You can just omit it from the rate law. Okay? All right, determine the rate value constant K, including units. So we have our rate law up here. We're just going to plug in a number, so let's just use trial 1. So we got 3.42 e to the negative 8, and its molarity, and I like to use exponents, seconds to the negative 1 instead of going molarity over seconds, is equal to, okay, we got to plug in the rate. It's 0.100, and this stands for molarity. So, and it's to the first power, so we could write to the first power, just leave it, times the NaClO3, and that's also 0.100 molarity to the, since it's to the first order, so it's first power. Okay, now, anyway, what that's going to do is if you multiply those all together, you're going to get 3.42 e to the minus 8 molarity seconds negative 1, okay, times 0.0100 molarity to the second power. I forgot the equals, and I forgot the k here. All right, k. Okay, divide both sides by 0.0100 molarity to the second power. Divide this side by 0.0100 molarity to the second power. Remember, you subtract exponents, so 1, let's see here. So a molarity minus a molarity to the second power. So basically, you got a 1 minus 2 equals negative 1. So I end up getting, if I do the math, I get that K is equal to 3.42 e to the negative 6 molarity to the negative 1 seconds to the negative 1. And those would be the right units. Okay, that's it for this video.